Hi, welcome. In this video, we will solve problem Fibonacci number on recursion. Hi. So now let's check out this one of the famous question Fibonacci number. Okay. And this is a most common basic problem in recursion. Okay. So if you are planning for if you are going in a company that is like more towards on coding assessments, coding rounds, but still like if they are going to be asked any DSA question, they can ask these types of question because these are the more basics ones. Okay, and then why we are solving basic question? So basically, we will get in this question, we are more focused on the dry run part. We are more focused on the recursion tree, how recursion tree basically forms. So now let's quickly check out this problem. Again, before solving it, I want you to go through the problem statement, understand the input and output. Now let's see. So a Fibonacci number commonly denoted as Fn, okay, form a sequence called the Fibonacci sequence such that the number is the sum of the two preceding ones. Okay. So basically the Fibonacci number, it will be the sum of the two preceding number. If you can see, there is one formula as well, right? Starting from 0 and 1. So they have said like the first number, right? Fibonacci, that f of 0 will be 0 only, and the second Fibonacci number will be 1, right? But after this, any number greater than 1, any Fibonacci number going to be greater than 1 will be the sum of two preceding number. So 0 plus 1, what will be the sum? That is 1. So this is my second Fibonacci, or you can say third Fibonacci number, f of 2. Now what will the next term? Next two preceding terms, right? 1 plus 1, 2, right? So it will be fib of 3, right? Similarly, the next two preceding terms, 2 plus 1, that will be 3. So it will become f4. The next two preceding terms, 2 and 3, then it will become 5, right? So it will become f of 5, and so on. So here you can see, like, let's quickly check out the example. So in example, when n is equals to 2, so when n is equals to 2, here you can see you are getting a Fibonacci number as 1. When n is equals to 3, you are getting a Fibonacci number as 2, basically the sum of preceding two terms, right? So this series will go, right? So first of all, 0, 1, then the sum will be 1. This will be my next preceding number, then the sum will be of preceding two numbers will be 2. So then it will be 2, then 2 plus 1, 3, then 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, and this series will simply move on, right? So Fibonacci was the like Italian mathematician, right? So he constituted a very one good this series, right? And there is a like lots of, we use these series, maybe some in golden rule, okay, and some on mathematical concepts, right? But it is a great example for our this recursion problem. So let's see how we can solve it. How basically our goal is to come up with if there is an n 1, 2, 3, we need to come up with the solution, right? What will be my Fibonacci number? So let's see. So this is fib of 0, fib of 1, fib of 2, fib of 3, and so on. So again, here you can see any number will be the sum of last two terms, right? Preceding two terms. So I can get a one basic general formula that f of n will be f of n minus 1 plus f of n minus 2, right? So these are, so suppose for 8, these are the two Fibonacci numbers, right? So fib of n minus 1 and fib of n minus 2. I'm just basically pronouncing f equals to fib, right? So please don't mean it. It's mean basically Fibonacci number, right? So this is a basic formula also of Fibonacci number, and you can basically again solve these questions on Leetcode, right? We have a pretty good problem statement there. Now how we are going to solve it, what will the code of it, and how we will use recursion. So basically in recursion, what we basically do, we call the function again and again, again and again, again and again. So suppose for this function, if we call suppose f of n, don't you think our solution of this f of n, right, will lies of f of n minus 1 and f of n minus 2, basically plus. So basically, to finding the solution of this f of n, what I want f of n minus 1 plus f of n minus 2. But then for f of n minus 1, what I want f of n minus 2 plus f of n minus 3. Don't you think this series will go on? Again, for f of n minus 2, what I want? So here f of n minus 3 plus f of n minus 4, and this series will simply go on, right? So you can see for f of n we want this, for f of n minus 1 we want this. So we are getting a sense of recursion, right? Basically one function calling one more function, then one function calling one more function, and so on, right? So basically we will solve in this direction only, right? So what we will do, we will basically create one function. Okay, so suppose my function, okay, again that's a pseudo code. Suppose my function is fib, okay, and I'm interested in finding fib of n. So my fib of n basically will return the same function, fib of n minus 1 plus fib of n minus 2, right? And this series will go on, right? So here you can see f of n minus 1, f of n minus 2, and f of n minus 3, and so on. So when I need to stop, so you can see we have already some Fibonacci numbers, right? Initial numbers. So f of 0 and f of 1. So these will be our stopping conditions. These will be our stopping points, you can say. Okay. Also in recursion term, you can say these as base condition. Okay. So similarly, what I will do, I will simply say if n is equals to 0, okay, or n is equals to 1, what do you need to do? You need to return n. Return n means if it is 0, return 0. If it is 1, return 1. So you can see fib of 0 is 0, fib of 1 is 1, right? Yeah, this will be our basic solution, right? I will just simply put this to a little bit forward, and this will be our going to be a function. So now let's do a quick dry run of it to understand it more clearly. I am using n is equals to 4, and we will create one recursion stack. So let's understand by recursion stack and recursion tree. So what I will do, I will first call this function. So I will call fib of 4, right? I will call this function. So if I'm calling it, right, I will simply write f of 4, that is fib of 4, okay? Because there is no much space, that's why I'm writing this. So I am calling this fib of 4. Let's make a tree. So now is your n is 0? Is your n is 1? No, it is not. So it won't come under this condition. It will say return fib of n minus 1. So I will return again one function call, that is fib of n minus 1, that is fib of 3, right? Plus fib of n minus 2, right? So I am just putting a dot because this is right now not called. This function is called, right? So first this function will execute, then we will come to this function, right? Always remember, so one of the function is called, first this will execute. So f of 3 will first execute, right? But I'm just picking a dot line, so we'll get to know that this will come later. Okay, now first I will execute fib of 3. So if n is 0 or n is 1, no, n is 3, right? Again I will come here and again one function called fib of n minus 1, then I will come to n minus 2. So let's call the next function, that is fib of n minus 1, that is 2. Again one function called fib of 2. All right, and now again there will be one dotted line. I'm not just adding it, it will be right in future. Now again let's execute first fib of 2, right? Is n is 0, n is 1? No, n is 2 here. So again I will come here and return fib of n minus 1. So again one function call, and I will return fib of 1 first. Again one function call f of 1, right? Now I will first execute this one, right? Fib of 1. So fib of 1, is your n is 0 or n is 1? Yes, now n is 1. All right. So return n, return 1. So basically this function will return 1 to it. Okay. This f of 1 now will return 1 to it. Now once it is returning 1, can I say my work of f of 1 is complete? Right? This function is complete, fib of 1. So it will basically return what? 1 to it. Okay. And after this function is completed, it will removed from call stack. Now we will move to the next function. Fib of n minus 1 is done. Now we will move to the next function. What was it? Fib of n minus 2, that is fib of 0. Again one function call, right? So first I will execute f of 0, fib of 0. Okay, again, is n is 0? Yes, it is. So return n. So it will basically return 0. So again here, what will the answer here? The answer will be 0, right? So I will return 0 to it. Okay, and I can say that this will return 0. So this function is also completed. Fib of 0 is also completed, right? Yes. So fib of 0 is also completed. It will removed from the call stack. So now you can see fib of 1, so fib of 2 value was depending on fib of 1 and fib of 0, right? Plus. So I am getting 1, right? And I am getting here fib of 0 is 0. So 1 plus 0. Can I say my fib of 2 is also completed? Because fib of 2 depending on fib of 1 plus fib of 0, fib of 1 is 1, fib of 0 is 0. That is the answer. So yes, fib of 2 is also completed. The value is 1. The value is 1. I will say simply that will also remove from the function call stack, right? And this will return to fib of 3. Okay. Now again here, this fib of 2 work is done, right? Fib of 2 work is done, right? But again, we need to check the next term, that is fib of n minus 2. That means fib of 1. Okay. Fib of 1. Now this fib of 1, let's execute this function f of 1 first. Is n is 0? No. N is 1? Yes. Again n is 1. So what I will do? I will return 1. So I will return 1. I will return this 1 to it. Right. So I will return this 1. Okay. Can I say my fib of 1 is also completed? Right. So I will simply remove from the function stack. And now you can see fib of 3 depending on fib of 2 and fib of 1. Fib of 2 is 1 and fib of 1 is also 1. So 1 plus 1, 2. And that is your answer of fib of 3, right? So this function is also completed, right? It is returning 2, right? So yes, it will return 2 and this function is also completed. We will again come back to the next function, that is like the last function fib of 4. But before fib of 4, fib of 3 is done, right? The next call was fib of n minus 2. So we need to complete this fib of 2 first, right? So again fib of 2 we will complete. Is n is 0? Is n is 1? No, it is not 0, not 1. So again I will return fib of n minus 1 and n minus 2. I will return fib of 1, then fib of, first of all, fib of n minus 1, 1, and then fib of 0. But we will come to this part later. First we will execute fib of 1. So what I will do? I will first execute here. We are executing fib of 2 and then one function call fib of 1. Now, is n is 0? No. N is 1? Yes. So yes, return n. So it will basically return what? 1. Okay. Now after returning it, we will again move to the next function fib of n minus 2. What is n minus 2? That is fib of 0, right? So 1 is done. 1 is done, right? Next function call is fib of 0, right? I will first execute this one. So fib of 0, is n is 0? Yes, return n. So it will also return 0. Okay. Now fib of 0 is also completed, right? It is returning 0. So I will simply remove from the function stack. Now fib of 2 depending on fib of 1 plus fib of 0. So can I say both functions is completed 1 plus 0? That is my fib of 2 answer. Yes. So fib of 3 was returning 2. Fib of 2 is returning 1. Can I say 2 plus 1? That will be my answer for fib of 4. Yes. So that will be an answer of, that is 3. So fib of 4 will be 3. And you can see fib of 4 is 3 here. Right. So this is how it will work. And fib of 2 is completed. This will removed. And fib of 4 is also completed. This will removed. And our recursion stack is empty here. Okay. So you can see this was our recursion tree. And that was is recursion stack. Now let's talk about time and space complexity. Okay. So first let's talk about space complexity. So here you can see we are not taking any extra space here, right? We are not taking any extra space, any additional space. But our recursion stack, right? This memory was getting increased. This memory, recursion memory was getting increased, right? So that is also one of these space. When we have lots of function call, sometimes you will get max memory limit exceeded. It's because we have an infinite function calls. right? So how these are function calling? So basically you can see fib of 1 say fib of 3, fib of 3, fib of 2, fib of 1, and so on, right? So our memory is depending on this like 4, 3, 2, 1. So here the space complexity will depend on the maximum, you can say the maximum root of the your recursion tree or maximum branch of the recursion tree. So let's conclude space complexity in a next window. So I will basically copy this recursion stack and let's see it here now. So let's first talk about space complexity. Okay. So we are calling function one by one, right? So suppose we are calling f of 5, then f of 5 will call f of 4, then f of 4 will call f of 3, then f of 3 will call f of 2. So you can see there is a decrement of 1, right? If I say that, you can see there is a decrement of 1, okay, in all the series, and it will go reach to the 0. So if I am taking n, right, it will be n minus 1, then n minus 2, then n minus 3, and so on, right? So your space complexity is always depends on the longest branch. So basically suppose this is your recursion tree. Right. So it will always depends on the longest branch. So suppose if I am considering that this is my longest branch. Okay, this is my longest branch. So this is how it will depend on the longest branch of the tree, and it is basically incrementing like it is decrementing by 1. So the space complexity will be big of n, right? Because there will be the maximum, right? What could be the maximum size of your recursion stack, right? It will be the n, because suppose it is starting from n and it will go till the 0, right? So again it will be on recursion stack and space complexity will be big of n. Now let's talk about the time complexity. So here you can see we are getting first two branches, right? So these are the first two branches. You can see fib of 3, fib of 2, then fib of 3 is again two branches, and fib of 2 again two branches. So similarly here again each branch has again two branches and again two branches. So first we have two branches, then again now we have four branches, then we have eight branches, and then we have 16 branches, right? So it is making not 16 branches, basically nodes, right? Function calls, you can see. So two function calls, two function leads to four function calls, four function leads to eight function call, eight function leads to 16 function call, right? So how much time it will take? Basically we can simply say 2 plus 4 plus 8 plus 16 and up to a series. So here you can see by this series R will be your 2, right? Right, this will be your 2, and this is one of the GP series. So again the how you will conclude the time complexity, the time complexity depends on the number of function calls. So 2, 4, 8, 16, right, and so on, right? So this is the our GP series, and what will be our A? So the A will be the first term, and if you can remember how we simply find the sum of this series, the formula will be A r power n minus r minus 1. If I apply the same formula, it will be 2, r is 2, 2 power n minus 1 upon 2 minus 1. So this will result as 2 power n plus 1 minus 2. Okay, and in time complexity we always take the highest term, highest degree term. So I will take 2 power n plus 1, and this n plus 1 it's nearly equals to n basically. So I will say simple 2 power 10. Okay, we can ignore, there is not much difference in n plus 1 and n. Okay, so we can simply ignore, and the time complexity will be big of 2 power n. So here the time complexity will be big O of 2 power n. So yeah, that's it for this Fibonacci recursion problem. Okay, and I hope you got so much here in recursion tree, recursion stack. And if you prepare this question, okay, if you are getting some recursion type of problems, you can create recursion tree. You can comment on their time complexity, and it help really like really well, because in an interview is going to interview wants that a person should know about recursion tree, recursion stack, and all these things. Okay, please prepare any recursion question with the full knowledge of recursion stack, recursion trees. Okay, so that's all for this video. We'll see you in the next video.